Hello and welcome back to the lab. Today on the bench we have a couple of curve tracers, actually three of them. 1, 2, and 3 is going to be back here where it usually lives. I've been getting a lot of questions recently on curve tracers, things like that. People are discovering the alignment and calibration videos that I did very, very early in the channel's inception. I do apologize for some of the roughness of those videos. The information's good, but I was not as good behind or in front of the camera when I recorded those. So, good information, but even I will admit they are a little bit on the rough side. But these are wonderful units, and I'm glad people are picking them up and saving them from the landfill and the dumpster and things like that. They're also wildly capable units, and I think still have a valid place on a workbench today or in a workshop. But I play on a wide range of electronics and need a bunch of capabilities that a shop that was more focused into something wouldn't necessarily need. But this video is going to be in response to some of the questions that were asked on the Patreon page and in the YouTube comments, and just a little bit of background information on these curve tracers, what to look for when you're looking for one, evaluating one for potential purchase, things like that, and kind of get into it. We have the two primary ones from Tech. There were two others. I am still looking for a 570 in the lab. I do not think I'm going to add a 575 unless there's a bunch of people on YouTube that would like me to do a 575 and take one through the process, get it up and running. Obviously recording that. Its functionality is duplicated in these two units and then some. Anything that the 575 can cover, the 576, which usurped it, and the 577, which came after the 576, all the 575 functionality is duplicated. The difference in the 570 is the 570 was actually for tubes. So not many of them have survived, and they're getting very, very rare. I am in the lookout for one, so if anybody knows of one, let me know. This video is primarily going to be a evaluation and buyer's guide of these wonderful units. If you decide you need to acquire one for your own workshop, just some things to look at and help you get started. The first unit we're going to take a look at is a Type 576. Now, this unit, getting it shipped to you uninjured is quite difficult. The shipping weight on this unit is 92 pounds. It is extremely heavy. The reason it is that heavy is because it has a variac underneath this control. It has a main power transformer in the back. It has a collector transformer in the middle, and it has a high voltage transformer up top. The high voltage transformer we'll get into in a little bit. That's small, not a lot of weight, but the two main transformers, the power transformer and the collector supply transformer, are extremely heavy. Moving this unit around the lab is difficult to say the least, and I'm also very careful as to what table I put these on, because I have two of these that are repaired. I have one more parts unit because I fell down the curve tracer rabbit hole and ended up really wanting to get one of these to work, and I got 2 out of 3, and the parts unit, we'll get into why it is a parts unit. Main difference on the 576 is there's a readout display here that shows you some of the settings. Great for taking pictures of curves for, say, data sheets, instruction manuals, things like that. And one of the things it was used for, there was a camera that would sit over the CRT and let you take really nice pictures of the curves plus the settings of the unit. The display unit used some light pipe technology and some decoding ICs and a bunch of incandescent bulbs. So people who took care of these units, they ran the display intensity very low to save the life of the bulbs. This is what that card looks like. The bulbs and the light pipes are in these shields. I'll pop one off just so we can take a look at it. I am evaluating replacing the lamps with LEDs, possibly doing a full LED replacement. That will be very time consuming. I have to change some current limiting resistors on here to keep the decoder ICs from getting burned out, so there's a lot of stuff that needs to be done before I can say I have officially made progress on that. But the LED boards So the light pipes, you can see, are nestled in here, and the the bulb boards, these aren't LEDs, they are incandescent bulbs. They're back in here, so you have to pull. Getting this out even on camera is being exceedingly difficult. So you can see this plastic frame with the incandescent bulbs in it, each bulb for the light pipes, and these ICs decode the signals coming in from the edge connector, and I activate the lights when they're supposed to be turned on. I need to be very careful not to overcurrent the ICs with the LEDs, because one of the reasons why I'm handling this unit is we can see there's an X marked on this tech chip with a proprietary tech part number, and that's because this board is faulty. One of the driver chips is fried up, so I'm losing segments on every single display. Actually, two of the driver chips are fried up, and every single IC on here is a custom tech part that was used in no other piece of equipment. That will be a common theme with the 576. There's actually lots of custom parts that were used in no other piece of equipment. So aside from donor units, there's not really any way to get new parts if something's fried up or bad. So if you are lucky enough to have a 576, be careful with the displays or with the readout, and run it at a low intensity to give those lamps the longest life they can. Tech did spec a very long life lamp in that position, and a lot of them have withstood the test of time. This board's toast, but the bulbs are fine, and I have not had to replace any bulbs in either of my tech units, and the driver ICs are dead in this one. But so lamps tend not to be a problem, but running them at full intensity for hours and hours and hours and hours and hours, you're going to burn some lights out. So let's assume you have settled on a 576, and you're going to want to dive down the rabbit hole and see what you have to do to get it running. Well, the 576 was, from what I've been told, was a curve tracer that Tech built internally for itself and then realized it was a product. It was never designed from the get-go as a consumer product. It was supposed to be an in-house unit built by a couple of the engineers that ended up turning into a product. So there's not a lot of mass production optimization in this design. So I don't know if Tech sold it at a loss. I don't know if Tech barely made money on it. But the fact that it uses a lot of unique parts that are unique to this unit means it wasn't really optimized for mass production. Typically, mass production tries to use off-the-shelf parts to make actually construction costs as cheap as possible. Also, shipping this unit, when you compare this with a 577, which was built for mass production, at a 92-pound shipping weight, the 577 is significantly less. It's way lighter than a 576. This is a very early serial number, which is something you want to look for, because they have some known faults in them. One of them is, if you take a look at the tube, if we look at the very corner of this tube, you will only see a point right here. You will not see these arrows etched into the graticule. On the later CRTs, those arrows are present. So what those look like is right here. So we have these black arrows coming up on the sides. Those are present on the later CRTs, not the very, very early ones. So that tells me this particular curve tracer has a Gen 1 CRT, which I wanted because it was a very early unit, and I don't see many of those in photos, so I wanted a Gen 1 version. The problem with the early serial numbers is the high voltage transformer, which is right here. So one of the common questions I get is, well, what's up with the, is this a good one to buy? First response that I'll look at, or that I'll give back, is check the CRT for double peaking and check the high voltage transformer. Make sure you have the black one. This is not the black one. This is the brown epoxy one. all of these are bad at this point. They have a leakage current that's coming out of the epoxy, and the behavior that mine exhibited was it would run for about a half an hour, and then it would act like it was power cycling. It wasn't really power cycling. What was happening is the 75-volt reference rail was collapsing due to the overcurrent being tripped because of the power transformer. The transformer was cooling off, overcurrent was hitting, and then it was coming back. So I'd hear this clicking on the bench. It was like on, off, on, off, and obviously not healthy for the unit. But that was the symptoms that my high voltage transformer exhibited. The parts unit I had the silicone transformer, so I ended up putting the Tech transformer in here. I do have 2 spare transformers. One of the other guys on the TechScopes forum, he had some that he had wound custom for some units, and he said, I know a lot of people use them and had success with them. They are currently unavailable because he did a run, and they sold pretty quickly, but they are unavailable at the moment. But I do have 2 of those for spares just in case my units decide to have trouble. If I ever get another 576, I doubt, 2's enough, but if I ever get another one, I may try to rebuild my parts unit, but that part unit has a dead CRT, which is the next problem with the 576, is the CRT is unique. It's used nowhere else. You can't cannibalize another scope. You can't do anything like that. It's done. The double peaking in the CRT, what we're talking about when we reference that is when you take the intensity control of the unit and roll it up through its range, you should see a steady increase in brightness as you roll the intensity control up. Double peaking is it goes up, it comes down, and then it goes up again to a final peak. My other CRT is exhibiting that behavior. From what is general consensus as to what's going on to that, obviously opening the envelope is quite difficult, especially with a loss of vacuum, is the cathode's getting poisoned. So that denotes a high hour CRT. I have had also the CRT will usually be fairly dim at that point. From what I've heard, I haven't tried it myself, so this is secondhand information. Tube rejuvenators will work very temporarily, and I'm talking like 6 hours. So I know some guys, they'll blast the cathode with some current to try to bake off the poisoned cathode in the emitter. What will happen is it will work. The CRT will work very well for a limited amount of time, 6, 12, 24 hours, and then it'll go back to exhibiting the poison behavior again. Unfortunately, CRTs are in short supply for these units. There is no LED or LCD replacement for that. That's been kicked around a few times. I'd love to see one, because if I got an LCD replacement for mine, that would solve my high voltage problem. That would also solve my CRT problem, so I'd be able to bring that unit back. So if we ever get to a point where those parts are available in any way, I'll do a video on it. The other thing that would be good is, or the other thing to know is, I will need to throw this transformer back in if we do that, because this transformer also creates the 200 volt rail that the CRT needs. So you get the acceleration voltage off of this side, but you get a bunch of power, higher voltage power rails off of the lower voltage side of the switching transformer. So still need to put this in, but it does look like the leakage is on the CRT side of things, and the power supply is, so if you disconnect the high voltage supply, obviously you'll have no CRT, but the scope does stay running a little bit. Unique power transformer, make sure you have the right one. Unique CRT, no replacements. 2 unique power transformers, no replacements. One of the other sore spots on these that I know some technicians have been having some struggle with is these relays tend to have some trouble, but I do believe there's a viable option. I need to get some more information on it, but I do believe there's a viable option for the relays if they ever need to be serviced. You can see some of my capacitor work over on the low voltage board. There's a bunch of capacitors hiding behind two boards, so this is the low voltage regulator, the rectifier is behind it, the bulk caps are behind it, and that's what you have to replace if you're going to redo one of the power sections of this transformer. I found removing the tube was easier, and the first curve tracer video has that process in detail. One other word of caution while we have the CRT open for those who are not familiar with working on some of the higher voltage equipment, things like that. We have the focus potentiometer and we have the intensity potentiometer. One of the reasons for the plastic shields on these potentiometers and the standoffs on this side and a few other things is there's 4,000 volts on those pots. Those are in the high voltage supply. That's why they're on these beefier cables. So especially when working around those, take extreme care. The purple and white cable is what you measure the 3,920 volt supply going into the tripler for the CRT. So especially when working in this area, because there's a low voltage cap hiding right behind here. Actually, you can see one of the adapter boards that I used to swap those out. You've got the high voltage right here when you're working on it, so take care. One other quick test, if you do have a unit and it does pass all of the inspections to see how well it might have been taken care of, is you can do a quick test with the 0 cal and invert buttons. So what you can do is you can set it up in NPN mode where it's sweeping, normal mode, not DC. And then if you hit 0 and you use the position controls to line it up at the bottom corner, and then you hit calibrate, it should jump to the top corner. If it's jumping very well to the top corner, so if between the 0 and the calibrate buttons, if you can bounce it between those 2 points, the unit's in pretty decent calibration at that point. The other thing is this switch pack is in the drive line for the CRT. These switches are very known for getting dirty. They will cause lots of noise. One of the tests there is to grab the invert button and just wiggle it like this. And if the display is going nuts, that's a dirty switch. Don't worry about it. These just need some cleaning and servicing. Everyone I know that has a 576, these 3 switches need cleaning and servicing. So that's been in every unit. This ring is kind of a pain in the butt. Be careful with this control here. If you see this is punched in, you're going to have a real tough time getting this control back. The lip of this plastic is what holds the 10-turn pot in. So there's a copper spring on the back of here that kind of holds this in, but then this keeps it from being pulled into the case. If this plastic breaks, that control will fall completely into the case. That was the other reason why my parts unit became a parts unit, is this control was broken, this knob was busted, the CRT was bad. It had a good power transformer, but now it has a bad power transformer because I stole the good one out of it to put it in here to get this one working. It's still mainly together. If I could just solve some of these problems, I can get another one up and going. But the CRT and the power transformer right now, they're terminal faults. As we're talking about calibrating a 576, for those who have been with us for a little while, you guys will know I am not a fan of shelf queens. If there's equipment on the bench, I want to know it's within factory specifications so I can believe what it's telling me. The specification can be quite loose. I have some meters that aren't very accurate, but they're within spec. So that's kind of what I'm looking for in equipment that I'm using personally, especially when I'm servicing equipment for other people. A gentleman from the hive mind in the sky of the internet came up with one of these. I ended up purchasing it for him. This is the calibration fixture for a 576. There is no other use for this box other than calibrating a 576. This unit replaces the front porch, and it has all the loads and standards and capacitors and deflection ratios and things like that that you would need to calibrate the CRT on a 576. There is a second calibration routine. Do not feel bad if you do not have this piece of equipment. It is very easy to do a calibration without it. The hard part is you will need some decently high voltage capacitors. Some of the looping compensations and things like that. You need 1600 volt, very accurate mica caps to put in the test points to do the alignment and the calibration. So this has everything that I need internal to it, and it was checked at their Cal lab before they sent it to me. So I actually got a calibration report on this. This was not inexpensive when I purchased it, but it did get these units up off the ground and gave me confidence in their measurements. The other thing is this can put out some decent amount of power. So not only do you need very high voltage components to do the calibration, you also need some decent sized power resistors to do the calibration and alignment. So the standards for a 576 are wide and varied, and we haven't even gotten to the 176, which is the front porch, which is the other test fixture for this one. Both the 577 and the 576 both have a second test fixture. This is the normal one. I'll use normal in quotes. The 576 has a high power test fixture. The 577 actually is spec'd for linear circuits, so op amps, ICs, things like that, whereas the 576 is more for power electronics, 100 amps through a transistor, kind of things like that. Now, it's not continuous, it's pulsed, but it does do, if I remember it correctly, it does do a 2,000 amp pulsed, or a 2,000 watt power pulse into the device under test. It is possible to do one of these without the calibration fixture. There is no calibration fixture for a 577. So Tech decided to get away from that, and they sold a calibration kit, which was essentially a couple capacitors and resistors that you bought that they tested and were certified good enough to do an alignment. I do not mean to disparage anybody from grabbing a 576. They are wildly capable units. I have two that are fully functional here in the lab, and I do use them from time to time. I did end up putting a 577 on the bench because there is quite a bit of overlap between the two units. The 577 is much smaller and takes up much lighter and less bench space. Okay, the 577. The not even less capable, somewhat more capable in its own right, somewhat a little less capable, doesn't do as much power, but is a wonderful curve tracer in its own right. A lot more to talk about on this one. This one had quite a bit of service life and some more options. So this control got fixed, no more plastic bezel holding that in, so not a concern on the 577. The tube on the 577, there are units that share that tube, so if you do get one with a bum tube, there is options to harvest them from other units, and those other units, in my opinion, are less useful on the bench than a curve tracer, so I did not mind. I did need to scrap one of those units for a CRT, but the unit is only a 10 megahertz scope. So with 100 megahertz scopes on the bench, up to 300 megahertz, I willingly pulled the tube out of it and turned it into a parts unit. This switch is a pain in the butt on the 577s. It is prime for something coming down, hitting it, cracking it off, snapping it off, and you will very much find these 177 test fixtures with this switch just chopped off. There's 2 different production runs, and I think 3 different production runs of the 177, at least 3 different design iterations. I'm sure there was continuous production. The easy way to tell whether you have a late model or early model, one of my units is serial number 124, is the horizontal position switches. So they have a 10x zoom. If you push in and pull out, this is now a zoom control. With this style, which has the main position with then the 10x zoom position, to get more detail. This is the later model and actually functions a lot better. The magnification existed in the first production, but it was pull out the control, and the control got really touchy because the control didn't change. This is actually a multi-stack pot where you have a main pot and then you have a zoom, which is engaging a same taper length but a lower value pot, so it's easier to adjust when it's in high magnification. The earlier versions didn't do that, so these controls are much easier to use on the second, on the improved version. This knob is a little different on depending on which model or which generation of front porch you have. Sometimes they have pull tabs, sometimes they don't. This one does not, but some of these have a 2-layer knob or skirted knob with a LED to identify the range. This has a zoom knob that lights up when you identify the range. So in normal operation, the arrow tells me what I'm pointing to, which it's a little off, which is fine. But and then when you hit zoom, it shows you what it is from lighting up. Be careful cleaning the bottom of these. You can clean the paint off. This one's got some damage here. I don't know how well the camera's going to pick that up. Oh yeah, it does pretty well. Where the numbers have kind of been rubbed off over time. That was before it came to me, but this is the only knob I have that works with this front porch. The 577 comes in 2 flavors. First flavor is the normal one, and the second one is the storage tube. It also comes in 3 different CRTs. So on mine, I have the 10x10 grid. There's an 8x10 grid. And then they have the, I have the 10x10 grid in storage, and I think there's a 10x10 grid in, well, I know there's a 10x10 grid in non-storage because my other one has the same tube. I prefer the 10x10 grid. It matches the 576 a little better, but it seems to be one of the rarer tubes. It's not as easy to find. So first things first, on this one we have a D1, which is the storage flavor. There is a startup routine for this. If you're unfamiliar with storage tubes, we'll take the variable collector and pull it all the way down to nothing. This knob's a little busted. I'll have to do something about that. We'll turn the intensity down to nothing. We'll focus it, defocus the tube. We'll turn the brightness down to nothing, and we'll power the unit on. Now, first thing you want to do, storage upper and lower, brightness all the way up. What that's going to do is it's going to put a lot of flood gun current in, and the manual says, if I remember correctly, the manual says to do this for 6 minutes if the tube has been off for a couple of days. You're going to see it kind of bloom in like this. This is the storage function kind of coming back after a amount of storage. Now, what you'll see is it's not fully saturated the tube yet. This is going to expand over the time period as it warms up and bring the storage functionality back. If the unit hasn't been on, this procedure should be done, at least the manual calls out for it, for the storage function to function. So we'll let that warm up and we'll talk about some other stuff. Capacitors in the power supply, there's a couple small caps that are almost guaranteed bad. I know a lot of people replace them. I've had to replace them in the 3 units that I've restored. They tend to be resilient units. The 577 does not have a lot of problems compared to the 576. It shares tubes with things. The high voltage transformer has proven itself to be pretty good. This switch, you don't replace the whole switch, but there are centers available for this. It's a Switchcraft switch. You can buy a new center and get another switch if it's something that you would like to look for. If you're doing an alignment on these and you're really, really struggling to do an alignment on a 576, there is a separate alignment procedure for the 177. If you haven't done that, do that one and see if the alignment will converge on the 176 or the 576. And that I did run into that and found that one out the hard way, was because some of the balance points in the 177 were off, and that was causing my alignment on the CRT to not go well. The storage CRTs, they are very, very susceptible to burn-in. You can actually see a little bit of burn-in right here at the center. This CRT is very healthy for its age. I have a little bit of burn-in at the center, and I have a little bit of burn-in at the bottom corner and the top corner, but that's to be expected. That's where the spot stays when the variable collector's not on. Now, one of the other things that is a brightness thing with the 577 is the 576, the spot intensity doesn't change. When you adjust any of the controls, nothing happens. The brightness control is the only thing that changes the spot intensity. On the 577, there's a dimmer function on the variable collector. So when this control is at 0, it'll dim the beam current so it won't burn in the tube as badly. And you can see that by just moving it like this much is enough to wake it up and get the beam current brighter. So it's just something to watch out for. If it looks like it's a little low, try giving it a little collector current, obviously on a low voltage, and see how it happens there. And as we can see, bringing the flood guns in, we are getting a more uniform brightness. I'm seeing it fill out on this side of the tube and things like that. I can actually deflect. There's enough magnetism in that screwdriver to cause the flood guns to go a little funny. But so I can see the beam current, or the storage is filling out the CRT as it should. One thing to note is, from what I've been told, and correct me in the comments if I have been told incorrectly, is when you ordered a storage tube from Tech, it came with a card that said what you should set the storage voltages for. Obviously, we can't order new storage CRTs from Tech. They don't make them anymore. But unless you find one brand new old stock, which is very unlikely, the best thing to do is, in the calibration manual, the storage voltages that are listed should not be taken as absolutes. They should be taken as a guide. If it looks like the tube's being stressed because it's really bright and the storage is really bright, back it off a little bit. Dimmer is better for CRTs. So hammering them just burns in the phosphor a little bit. The other thing is, during the calibration process, if you're watching any of my older videos where I'm talking about calibrating a tube and aligning a tube, don't take what the tube's doing when I'm talking about some of the alignment procedures unless I'm pointing at the tube or a few other things. Because if I'm doing an alignment and you're following along, you're doing so at your own risk. If I'm doing an alignment and it's really hard on the CRT, like bright spot in the CRT, I will turn the intensity down and then record for you guys. I don't want the CRT baking at that high intensity while I'm getting the camera focused and all that other stuff. So I try to take the load off the CRT as fast as possible, because I do have to use this equipment in the lab for my own use in production. So it makes for a little bit of bad video, but it's more friendly on the CRTs. And they're a scarce resource at this point. Okay, so what does storage even look like? So I've erased the storage tube. So let's get some intensity going. So I have the brightness almost all the way down. I have a dot showing up there just at the beam, just at the kind of borderline of visible. We're going to sweep this. So right there where the screen kind of lit up, that's what I'm talking about when I am talking about the beam current comes in when the display dimmer goes out. So, and I don't have enough brightness there to really do much, so we'll add some intensity to the beam, and then so it's drawn the line. I'll turn the main intensity down. That line will stay there, and we can take measurements on that line, and I'm not hitting the CRT very hard. My collector current's all the way at the bottom, so it's not even running, but we have a line that we can use for measurements. So this is kind of what the storage CRT does. Now, some of the cool stuff you can do with a storage CRT is we could do thermal analysis of transistors. We can get some transistor curves, heat them up, cool them down, and at one of the bias points, the line won't move up or down. And what that's going to do is that'll tell us where it's temperature stable. So there's some neat stuff you can do with a storage CRT that you couldn't do otherwise, because back in the day we didn't have digital storage, and this is all we had. The alignment for a 577 is different than an alignment for a 576. The 577 never had a custom test fixture made to do an alignment on it. It always relied on a couple of standards, a couple of resistors, and a few other things. So the alignment, and a good DMM. The alignment is much more forgiving on a 577 than it is on a 576, and far easier to do. So given its pluses, if you don't need the capabilities of the 576, a 577 would be a viable option. You actually end up with 100 volts more on the collector. This goes to 1600 volts, where the 576 goes to 1500. The 577 is also able to go down to 0.2 nanoamps. So 200 picoamps of vertical deflection. The 576 is not that sensitive when it comes to its vertical. So we have and that's kind of where they were designed for. So the 576 is designed for the power band, power electronic, or power silicon. 577, small signal silicon, but we still can go to exceedingly high voltages, 1600 volts, and we have much better current resolution on the 577. The 576 only goes down to 1 microamp, although it can do 1 nanoamp in looking at base currents. So from a measurement standpoint, especially in small signal, 577 actually does a little bit better job than the 576. Turn off the beam guns. Between the CRTs, one of the other things to note is the storage CRTs are very susceptible to burn-in. The non-storage CRTs are normally susceptible to burn-in. Every CRT can be burned in, but the storage ones seem to have a tougher time with it than the normal ones. But it's all we had. So I hope that cleared up a few things and helped made the decision, if you decided to add a curve tracer to your lab, in what you should go after and what you should buy. There are very capable curve tracers. If you're looking for some small signal stuff, the Atlas Peak, the Pro version, can do curve tracers. Its limitation, though, is about 12 volts on the collector. I needed some higher voltage stuff, especially when I was repairing my Fluke 5200. The negative 190 volt rail burned up, and I had to evaluate some negative 190 volt Zeners, and I had to also evaluate some leakage current in some power silicon. One of the places where these units excel is if you have power silicon that's not 100% bad, but it's got a little bit of leakage. They really see the breakdown where it would be difficult in another way. So love having them in the lab. Not a tool that's used every day, but when it's called into service, it's the only tool that will do, at least from what I've found. So with that, as always, I will see everybody in the comment section between videos. Check out the Patreon page. I believe they're about 4 videos ahead at this point. So if you'd like a little bit more content and want to talk with me directly and interface with me there, check it out. And I will see everybody in the comments. More is always on the way, and your questions can generate videos. So ask away, and we'll see what we can get recorded. Catch you guys in the next one.